The command looked straightforward. Add a constraint to an existing table. The table had 43 million rows. The command ran. The database locked. Production went down for 19 minutes. Adding a constraint to an empty table is a declaration. You are telling the database what rules apply to future data, and the database notes this and moves on. Adding a constraint to a table that already contains data is something different. It is a reckoning. Before the constraint can be enforced going forward, the database must first verify that every row already in the table complies with the rule you are adding. Every row, all 43 million of them. And while it is doing that verification, depending on your database engine and your configuration, it may hold a lock on the table that prevents any other operation from proceeding. Think about a new regulation introduced for a storage facility that has been operating for 20 years. The regulation says every item in the facility must have a visible, legible identification tag. For new items arriving from today, compliance is simple. The rule is applied at intake. But for the 20 years of existing inventory already on the shelves, the regulation requires a full audit. Every shelf, every box, every item must be inspected. The facility cannot accept or release anything while the inspection is underway because the inspectors need unobstructed access to every aisle. The regulation is reasonable. The process of applying it retroactively to existing stock is an operational event of a completely different scale. A database constraint applied to an existing table is the same inspection. The rule is reasonable. The retroactive verification is the operational event. In 2023, a German e-commerce company decided to add a not null constraint to the customer email column of their accounts table. Email addresses had always been required by the application, but the constraint had never been formally declared in the schema. A compliance review flagged the gap. The fix was straightforward. Add the constraint. The accounts table held 43 million rows. The database team ran the alter table command during a scheduled low-traffic window on a Sunday morning. PostgreSQL, their database engine, acquired a full table lock to validate all existing rows before adding the constraint. The validation took 19 minutes. For those 19 minutes, no reads or writes could complete against the accounts table. Login attempts failed. Checkout sessions that required account lookup timed out. The customer service platform, which queried the same table for every support interaction, became non-functional. The compliance fix was technically correct and completed successfully. The constraint was added. The table had no null email values. The application had enforced this reliably for years. But the process of formally declaring what was already true cost 19 minutes of production downtime and an unknown volume of abandoned transactions during a period that, despite being low traffic, still carried active users. The constraint was right. The approach to adding it was the problem. This failure pattern has two distinct components. The first is the validation cost, the time the database spends checking every existing row, which scales directly with table size and cannot easily be predicted without testing. The second is the locking behaviour, the degree to which the validation process blocks concurrent reads and writes, which varies significantly between database engines and constraint types, and which is the component most likely to cause visible production impact. Different database engines handle this differently. PostgreSQL acquires a full table lock for most constraint additions, but offers a workaround. Constraints can be added in two stages. First, as not valid, which marks the constraint as applying to new rows only, without validating existing data, and then validated separately using a lower impact lock mode that permits concurrent reads. MySQL and MariaDB perform online DDL for many operations, but still carry risks for very large tables or older storage engine versions. SQL Server has its own locking behavior and its own mitigation patterns. The point is not that adding constraints to live tables is always dangerous. The point is that it is never automatically safe, and the assumptions that make it feel safe on a small table do not hold at scale. There are three things that address this. First, test constraint additions against a production-scale copy of the data before running them in production. A constraint addition that completes in 2 seconds on a development database with 10,000 rows may take 20 minutes on a production database with 40 million. The only way to know the actual duration and locking impact is to run the operation against data of comparable size. This is not optional due diligence for large tables. It is the minimum information needed to plan the operation safely. Second, use staged addition, where your database engine supports it. The PostgreSQL not valid pattern. Add the constraint without validating existing data, then validate separately with a weaker lock, is specifically designed for this problem. It separates the declaration of the rule from the retroactive verification, allowing each to happen with appropriate controls. Other engines have analogous patterns. Understanding which mitigation strategies your specific database supports is part of the operational knowledge required to manage constraints safely. Third, treat constraint additions on large live tables as deployments, not maintenance tasks. They need a runbook. They need a rollback plan. They need communication to support and operations teams about the potential impact window. A command that can take a production table offline for 19 minutes is not a routine schema change, it is a production event, and it should be treated with the same preparation as any other production event that carries downtime risk. The storage facility could not avoid the inspection. 20 years of inventory existed, and the regulation required that it be checked. What the facility could have done was plan the inspection differently, run it in sections, keep certain aisles accessible, stagger the work across several nights rather than closing the entire facility at once. The regulation was not negotiable. The process of complying with it was. Adding a constraint to a table that already has data will always require some form of reckoning with the past. The database will verify the existing rows, one way or another, because a constraint that does not apply to the data already present is not a constraint, it is a wish. The question is not whether that reckoning happens, it is whether you have planned for it, or whether you discover what it costs only after production goes down.